Okay, guys, inequality applications. Of course, you'll have your pre-recorded video here. So let's get started. First of all, we're going to talk about all the different words for the symbols. So this one, which I like to think what helps me is this is less than. If you think about it, it makes an L for less. If you think about that. So this is less than or fewer than, which we don't see as often, but sometimes we do see that. So if that one is less than, what would this one be? Less than or equal to. Equal to means it has the equal sign underneath it, right? The ones we use most often are no more than. So the ones that we will see most often, and at most. At most, I can spend $50. I can spend no more than $50. This one is also maximum or your limit. This would be the limit you can spend, okay? Then we have this one, which is greater than or more than. So be really careful. It's not, it's that sounds similar. I can spend more than $20, okay? It's a little bit different. So then over here, this one would be, of course, it has our equal to underneath it. So it would be greater than. Oops, let me change colors there. Or equal to. Okay, and the buzz terms we see the most are no less than. I can spend no less than $50 on my new purse. That would be great if I was told that every time. I have to spend at least $10 on every kid for Christmas. And then opposite of maximum, this would be the minimum I can spend, or the minimum I can work out is whatever our answer would be, okay? So then let's go down. Sorry, I don't have my mouse right now, so I'm working off of my touchpad. I'm not as good with it. All right. Karen went to a video arcade. The game she likes costs 75 cents per play. What is the maximum number of times she could play if she brought $8? So let's talk first. It wants us to write the inequality. It's 75 cents per play. So that's what's going to go next to your variable. What is 75 cents? What does that look like in money amount? It's going to be 0.75. So 0.75 times however many plays has to be, now she can spend $8, so it could also be equal to $8. So we're going to eat the $8 there because that's the most we can spend. So our symbol will, for lack of a better term, eat the $8. That means it's going to be less than or equal to. So then we're going to come over here and we are going to solve it. If I want to get the x by itself, what do I need to get rid of? What are the number and the letter doing? They're multiplying. How do I get rid of multiply? With divide. Okay, so x is less than or equal to, and when you plug it in the calculator, you're going to get 6666 repeating. Okay, can she play 0.66 of a game? No, you can't play 0.66 of a game. So I can't play more because if I played more, then that would be too much money. So the most games that she can play is 10 games. 10 games. Next one. The satellite will be released into an orbit of more than 400 miles above the Earth. The rocket carrying it is currently 255 miles above the Earth. How high must it climb before it releases the satellite? All right, so I'm already 255, right? How many more am I going to need to travel? So that's plus to be greater than. It can't be equal to, it has to be more than 400. So I'm going to eat the problem because I need the problem to be bigger. That's how I describe that. Okay, so now we're going to come over here and we are going to solve it. If I want to get that x by itself, what do I need to get rid of? What is next to it? The 255. How am I going to get rid of the 255? By subtracting. So x is greater than 400 minus 255 is 145. So it has to go more than 145, right, miles. It has to go over or more than 145 miles. And I think on the first one, I forgot to write, she can play, oh, no, I did 10 games, making sure. Checking my work. Number 3, a 15-foot tall cedar tree is growing at a rate of 2 feet per year. There's our key. Beneath power lines. The tree can grow no more than 58 feet before the power company will need to prune it. How long can the power company wait before taking action? So it is going 2 feet per year. And let's see, what is it? It's already 15 feet. So plus the 15 feet it already is, has to be what? Then that 58 feet. Okay, the 58 feet is the most it can be. Okay, so it's going to be less than equal to. So now, if I want to get that 2x by itself, what do I need to get rid of? What's by it? The plus 15. How do I get rid of plus 15? I subtract 15. So I have 2x less than equal to 58 minus 15 is 45. Now, if I want to get that x by itself, what do I need to get rid of? I need to get rid of that 2. When a number and a letter are right next to each other, what are they doing? They're multiplying. How do I get rid of multiply? Divide. So x would be less than or equal to 22.5. Now, this is a decimal. Can you have 22.5 of a year? Yes, you can. You can have 0.5 of a year. You always need to think about it like that. You can't have 0.5 of a person, though. I know we've already talked about that. So they can wait quite a while, it looks like, before they have to trim them. I wonder if that's actually accurate. I need to scientifically check that.
It would be depending on the aerial.
It would be depending on the area, is what my husband just told me. Okay. I'm talking about 2 feet per year for a cedar tree. All right. Wayne's homework is to solve at least 20 questions. Oh my goodness, that's a lot of questions. So far, he has completed 9 of them. So he's already done 9. How many problems must Wayne still complete? Now, I know y'all know the answer to this, but we're still going to write the equation so we can write it correctly. 9 questions plus how many needs to be greater than or equal to 20, because he wants at least 20, preferably more. I mean, don't get me wrong, we could gladly give y'all more work, not a problem. So then if I want to get the x by itself, what do I need to get rid of? What's by it? That positive 9. How do I get rid of a positive 9? With a negative 9. So x is going to be greater than or equal to 11. So that's going to be that he needs to complete 11 or more problems, right? Practice makes perfect. Perfect segue there for me. All right, number 5. Did set these up a little bit different for y'all. Kaylin must watch YouTube at least 5.5 hours each day. Oh, this so sounds like something for my son. Each day. She has already watched it 2.3 hours today. How many more hours must she watch? It sounds like this is definitely a real life scenario here. So we have 2.3 plus how many to make it at least. So she wants the least amount to be 5.5, which means we're going to eat the problem, right? And it can be equal to, correct? So we're going to rewrite the problem over here and solve it. Guys, remember, decimals, don't let them intimidate you. They're okay. So if I want to get the x by itself, what do I need to get rid of? The 2.3. So I have x is greater than or equal to 3.2. Okay, and what does that mean? She needs 3.2 hours or more. Man, I hope she didn't have those 20 questions for homework like the kid above. Yeah, that cut into her YouTube watching for sure. Number 6, different color. There are 24 students in your math class. If you have $60, what is the maximum amount you can spend on each student for a snack? So, what are we going to do here? Let's think about this. So, you're trying to figure out how much you can spend for each student. So, you have 24 students times X, but the most you can spend is 60. So, you're going to eat the 60, right? Because the 60 is the most you have. So, you're going to do 24x less than or equal to 60, right? Divide by 24, divide by 24. X is less than or equal to, I got 2.5. So what does that mean? The most you can spend for students is $2.50 each. Remember, you can have a decimal of money, guys. Kind of a different problem, but it's going to look like one that you're going to practice today. Grace brought $40 with her to the mall. She purchased a $5 piece of pizza and $5 piece of pizza and wants to buy some mystery bath bombs at Lush for $6.75 each. So there's going to be a decimal. What is the most amount of bath bombs that she can purchase with her remaining money? Okay, so $40. So let's talk about what she wants. She wants $6.75 each for the bath bombs, plus the $5 she already spent. Now, some of you might look at this and actually go, well, now she only has 35 left. And I'm okay if you realize that it's 6.75x less than or equal to 35, because that's what you're going to end up doing as you're solving the problem. So let's go over here and write it. Correct? So we want to get x by itself. What do we need to get rid of? What's by it first? The plus 5. How do we get rid of the plus 5? Minus 5. So you have 675x less than or equal to 35, right? Now, what am I going to do to get that x by itself? When a number and a letter are right next to each other, what are they doing? They're multiplying. How do we get rid of multiply? Divide. So x has to be less than or equal to, and I got 5.19. So what does that mean? Can it be equal to, can you have 0.19 of a bath bomb? No. So the most bath bombs that she can get are 5 bath bombs, but we all know 675, that's like Lush giving them away. We know they're way more than that. All right, guys, that's it.